Thanks for being here on the security track today. My name is Maik Außendorf. I'm from Bareos, and I would like to talk about zero-knowledge backups, or in other words, secure backups. First give a little introduction who I am and why I'm here. Then tell you about the vision of zero-knowledge backups, give you an overview of the open source backup solution Bareos, and finally tell you how we approximate the vision of zero-knowledge backups with Bareos. So anytime you have any questions, just raise your hands. We have enough time and shall have the possibility to answer any question you have in between or at the end, whenever you like. So my name is Maik Außendorf. I'm, which you might hear, from Germany. Studied mathematics more than 20 years ago. Started to use Linux around 1994 at my university at that time. Programming artificial neural networks on Linux and Solaris, which was probably a little bit ahead of time. But anyway, then I started my professional career as a consultant working with SUSE Linux in Germany, which was a pretty interesting time because many large corporations started to work with open source and Linux, and we as consultants were involved in most of those projects like Deutsche Bank or Ford or other global companies. Very interesting time. Then I founded, together with some other colleagues coming from SUSE, an IT service company focused on, again, Linux and open source called Das IT. And then in 2012, I was one of the co-founders of the Bareos project and the company of the same name. And I'm still working for that company, obviously being here today to talk about Bareos. And in non-work time, I spent mostly with my family, with winter sports here in the Swiss Alps, one of my favorite places, and doing local politics in my hometown. So where do I work? Name of the company is Bareos, blah, blah, blah. That's a formal thing, kind of limited in US or British language. So the company Bareos funds the project, pays developers bills. And what we're doing, we provide some services around Bareos for the community as well as for paying subscription customers. So whenever we have a new major release of Bareos, we of course have the source code completely on GitHub, but we also provide binary packages for almost every Linux distribution, for Windows, for macOS. That's done by the company, and that's free for everybody. We provide technical support, trainings, and we like to work with local partners all over the world who can deliver services to their customers on site, and we support them doing so. So zero-knowledge backups is like a vision. So if you do backups to cloud, the idea is that the provider shall have zero knowledge about what you store in their data center. That's not to be confused with the term zero-knowledge proof or zero-knowledge protocol. That's some theoretical stuff from encryption theory, but that's not meant here. We just see it here as a vision that a service provider shall have as less information about your data as somehow possible. So why is that important? If we talk about data sovereignty, you should command your data. I wanted to put a picture here of commander data, but due to copyright restrictions, I had to sustain from that. So, but this old safe or vault here, in older days, people stored their values inside such a device. And imagine you were buying a new safe, but the vendor keeps the key, and you have to pay ongoing subscription fees in order to get access to the key, open the vault, and get access to your valuables. Of course, in the old days, no one would have bought such a stuff or agreed to such terms. But what are people doing today? There are proprietary backup solutions around that may require ongoing payment to let you access your data. If you don't pay, your license key will get invalid and you can't restore your data. So that is really something happening out in the field. And what about the cloud? So if you leave your digital assets in the cloud, you have to be clear that cloud is just a synonym for someone else's computer. That means you leave your valuables, your assets, up to someone else. And the question is, are you able to retrieve, move your data whenever you want to do so? So that's a very basic questions, and that's true for almost every cloud services, not only for backup, but especially for backup. This may become crucial because if your primary source of data gets lost, this might be the last line of defense you have to get your business, your organization up and running. And here's one crucial point. I guess we all are here because we love open source. So when using cloud services, open source is really a must if you want to keep the data sovereignty, if you want to be able to control your data. So this is kind of some preliminary statements. Well, what kind of data if we talk about backup? So obviously you have all kinds of content on your PCs, whether you are a programmer, you have your source code files. If you are a writer, you have some text files, or musician, you have music files. Whatever, we call this simply content here. And then if you are a system administrator, you might have configuration files on your servers that are of some importance for your environment, for your operations. There might be database dumps, all kind of application data. So this is what we call data by means of backup. So what we backup, and we make redundant copies to be able to restore your business operations in case of some problems. The question is that all? And no, it's not. Of course, we also have metadata. And by means of security and what that could tell to someone, just imagine some medical program might name files after patients' names. So this is a crucial information if you store your files and make backups to cloud, and the file name is visible to someone else, that this opens the door for conclusions. Then there might be information about where this data comes from, so that could give hints about your network topology. Host names can be an entrance door for attackers, or at least interesting information. So these are all things to consider and think about if you are doing backups, or if you put or send your data to someone else's computer. And then you might have timestamps, which gives hints about a document history, for example. So just some examples. And permissions, of course, who has access to files is also kind of metadata that you have to store when you do backups, because when it comes to restore, you want to get all this information back, so this information has to go somewhere. So summarizing what zero-knowledge-backup is about as a kind of vision. So the minimum is the payload, the data itself must be encrypted, otherwise you just open the door for everybody to access your stuff. Regarding metadata, the lesser the better from a point of data sovereignty and privacy view. The optimum would be that nothing is visible to the backup provider. But that's hardly to achieve if you have everything organized inside the cloud, because there must be some meta information somewhere. And the metadata is needed to search and retrieve files from backup. And it's so also a matter of comfort and functionality. So you have to find a balance between the metadata you really need to get your operations done, and on the other hand, minimize the risk of exposing too many information to your service provider. So that's where we have to figure out our balance. So unless there are questions until here, I would now shift to give you a little bit an overview of what Bareos is doing. Yeah, what is Bareos? First, the name is an acronym: Backup, Archiving, Recovery, Open Sourced. So some pronounce it Bareos, but that's not the way. It's not operating system. The OS stands for open source, so the name is Bareos. And I said before, that's completely open source. It's extensible by means of the architecture. We have several scripting interfaces. We can have pre- and post scripts for our backup jobs. We have a Python plugin interface, so you can write your own Python stuff or C++ if you want to address certain application needs for backup. It is network-based. Of course, it doesn't make sense to back up just one machine, so it's designed to back up data from all the machines in your network. It's multi-platform, so it originally comes from Linux, and the server runs in most of the time on Linux. But we also have clients and also the server component for Windows, for macOS, for FreeBSD, and for several older Unixes. It's scalable. Many people run it in their home office or in their home network, but we also have customers and users that are really large. So for example, the National Archive of the Netherlands or the Bavarian State Archives. We have some large universities with petabytes of data. So it scales very well from slow to real big. Yeah, and it's a backup software, and that means, so here's an overview. You see on the left column the things that we can back up. So I said before, Windows client, Unix, Mac clients. We also have a dedicated plugin for VMware. That means we can snapshot virtual machines and make incremental backups of those machines. The same is new and not on this slide. We can do with Red Hat virtualization using the overt API. We can back up from several cloud storages like Gluster, like Ceph. We have plugins for Microsoft SQL Server, MySQL to do incremental database backups and point-in-time recovery. And we can also talk to NDMP devices like NetApp storages, for example. Then in the middle column, you see the heart of Bareos, the Bareos server. That is where everything is configured. And then we write to the left column to, most people write to simple disk storage. Yeah? Yeah, the question was, do we have any container offerings? We as Bareos, we do not yet build containers, but there are some community containers around, some with more than 10K downloads, so it seems to work, but we haven't tested them by now. We will do something by ourselves, and we are also working on backing up container environments, so if it comes to configuration and persistent data. But that's an early stage. We are talking with people from Red Hat, customers who should tell us what they expect when it comes to container environment backups. But still, you will have persistent data, configuration data, and we are working on that. Yeah.
Do you think within a year you would have something else?
Yes, we hope so. Yeah. It's on. Yeah, you're welcome. It's on the roadmap later. So yeah, we are working on that. So right now we can back up to S3, for example. So any storage that exposes services by S3 protocol can be addressed to store stuff to, like Amazon Glacier or so can be used. Then of course still disk, and a lot of people say, well, tape, that's dead, but it's not. So we support large libraries. We have big customers with really large tape libraries, and it has some really big advantages. One is it's cost efficient, at least if you're talking long-term storage. It saves energy because a tape does not need any power when it's lying around somewhere compared to a disk. And it's offline media. So when we talk about, let's say, ransomware attacks, they won't go into your offline media. So if you have a certain amount of data and want to store it for a certain amount of time, just do the calculation. Of course, cloud is always easier to implement. It's faster, it's nice, comfortable, but it's wise to do the calculation if tape is an option. And for most large organizations, it really is an option. So this is more the overview and the marketing slide. I would like to go a little bit deeper because we will come back to the technical stuff when we talk about secure backups later. So when we talk about the Bareos server consists of 3 components. In the middle, top is what we call director. That is a central daemon running. That is where you have your configuration. That's where the scheduler is. That's where the text and web UI interfaces connect to retrieve information, to trigger jobs, and so on. So that is the heart of the system. That's a classic Unix or Linux daemon running on a Linux machine. Then to the right, what is named here catalog is an SQL database. There we store all kind of meta information, which job has run, at which state, when did it start, when did it end, how many data, how many files are in it. We have the job logs, and we have the information about all the files we have backupped, including timestamps, permissions, checksums, and so on. That's all in this SQL database. And then the third component is the storage daemon. That's another daemon running, and the only job of this daemon is to write data to one of the storage devices shown on the right here. So, as said before, it could be a disk or tape or some cloud things. So these three components play the role inside Bareos: the director, the catalog, and the storage daemon. We will come back later to that when we look a little bit deeper into what's important when talking about secure backups. So some of the key features already said. We have the catalog database. Of course, we support encryption. Since the version we have published last year, transport layer encryption is pre-configured, so you have to do nothing. You don't have to care about certificates and whatever. If you start Bareos and server and client are at least on version 18, the whole transport layer will be encrypted automatically. Then, go back here. Of course, the backup data itself can be encrypted by certain ways. It could be by individual keys per client, and it also could be by a central master key running on the Bareos server. And you could also combine those. So just in case that a customer or internal client forgets or misses his key, you can restore using the central key. And of course, you have to take about special care if you're using a central key. And the third way is, if you're backup to tape, modern tape drives support hardware encryption. So you can load a key inside the tape. That is then the fastest way, and Bareos will maintain the information which key is used for what backup inside its database. So it's firewall friendly. That means basically two things. One is we only use a limited set of port numbers. Actually, there are 3 ports we are using for the several way of communications we do between client, director, and storage daemon. And if you talk about DMNets, we have several ways to make sure that the connection initialization can go from either side. So you can, if you prefer, open the connection from server to client, but you can also say, I have certain clients here that should connect from the DMZ to the server, so that we are flexible and can adapt to your topology as needed. Yeah, then as said, we support NDMP to address large storage devices. We have a plugin interface for Python. For example, the plugin that backups VMware snapshots is written in Python, as well as a plugin to backup MySQL, for example. So what's particularly new in the latest version? We did some internal changes for those of you being or are acting as software developers that might be of interest. So we have what we call master branch, where we do all the latest edge work. And whenever we do changes or bug fixes, we first do this in the latest branch and then backport to the stable supported branch. And we also publish packages almost nightly, or whenever we do a commit, and you can install pre-built packages on your systems to test the latest stuff. And that's almost pretty stable because it runs through our complete automatic test set. So even the nightly branches or the nightly packages we publish usually have a quite high quality standard. So yeah, and we adapted the GitHub flow, and this way we managed to get more and more community involvement. So for example, the web UI now has more than 10 languages supported, and most of the translations coming from the community. So improved automated testing, we now have the policy that whenever a new feature is developed, that at the same time we have to have an internal test routine, and everything will be tested completely automatically against those tests. Continuous integration means we are doing this from the beginning when we started in 2012 to build packages for the distributions we support, and then we will fire up virtual machines with a corresponding Linux distribution inside, install the packages, run backup and restore jobs. We have been doing this all the time for the releases we had, but now we extended this to pull requests. So whenever someone has a pull request on GitHub with some code changes, we build packages based on the pull request and test if this works in all the different environments we have. So this gives a really good or improved standard of quality. And then those of you who might have had a look at our documentation over the last years, we started with some legacy stuff built upon LaTeX, which was nice in the 90s. But now we've changed to RST and Sphinx, and that is the same framework that, for example, Python uses for its documentation, and it makes it much more fun to read and search for stuff inside the documentation. So some new features that we have in 19.2. We now officially support the Percona Extra Backup plugin. So Percona is an open source related company. I think they also have a booth here. They are very active around MySQL, and they've built a tool called Extra Backup to make incremental backup and hot backups of a running MySQL database, which also enables users to do point-in-time restores based on log sequence numbers. And we are using this Extra Backup tool inside Bareos to make MySQL backups. And that's now also officially part of our distribution and is supported. Then we have the over-threaded virtualization plugin to do snapshot backups. And that makes use of the overt API. And this API for now has a limitation. It only supports full backups right now, but it is on Red Hat's roadmap to also support incremental backups of virtual machine snapshots. So as soon as the API exposes this feature, we will also have it inside Bareos. Then we had something new for roaming users. So if you want to back up your laptop and you have users that are traveling a lot, not being in the office every day, it's now much easier to back up those laptops, as we can now define commands inside the director what to do if a specific client connects to the director. So that means if some of your salesmen comes back into the organization, or some researchers traveling, coming back, and connects into your network, the backup job can immediately be triggered to get the data as soon as possible from this machine. Then we have a DB copy tool. The background is, right now we support, yeah, question?
On the job, you do incrementals also, or is it the full backup on the client connect?
The question was if on the client connect it's incremental or full. It could be anything. It's about your definition. Usually we do it in a way that we define how old the existing full backup may be. And if it exceeds a certain limit, let's say 30 days, and the client comes back and you trigger an incremental job, it will check how old is the oldest full. If it's too old, it will automatically upgrade the incremental to full. Yeah, okay.
You could also, if you're backing up to block sorted disk, you could do forever incremental, right?
Yes, the question was about if we could do something like forever incremental. We call this feature always incremental. Yeah. Yes, so I think we have some time, so I'll tell some words about it because it's quite complicated. If you think about doing always incremental, the question is why not? So do one time a full backup and then for years every day just do incrementals. That works fine. The problem is if after, let's say, 2 years, you have to make a complete restore. And after 2 years you have one full backup, and more than 700 daily incrementals. And then you would have to pick every single incremental job to get the state as it was yesterday. And that may take ages. So what we are doing when we are talking about always incremental, we are consolidating the incrementals. So let's say we keep like 7 incrementals the last week, which enables us to restore the state from every day over the past week. So what's older is not possible. It will be the last state. But what we do is we consolidate the older incrementals into one job. And that means even after 2 years, we only have the full job and 1 incremental and maybe 2 or 3 additional to restore very quickly. And that's, yeah. Yeah, right. It's so always incremental is suitable for VPN or for very large backups. So we have some research organizations, they have petabytes of full backup, and if they do a full backup, that blasts their network for 3 or 4 days or even more. Yeah, and that's a killer feature. I wanted to be sure people knew about. Yeah, okay, thank you very much. Thanks. Okay, so where was I stuck? Right, the DB copy tool, that's right now as catalog we support MySQL and Postgres, but we decided to reduce this to Postgres only. Because, well, MySQL, what is it? Is it MariaDB? Is it, don't know which version? And we don't see really an advantage of having a lot of catalogs on the back end. And Postgres gives us the most feature by means of performance. And the DB copy tool will help us in the future when at the point where we stop supporting MySQL, this tool will copy an existing MySQL catalog into Postgres. So we are preparing for that. And we want to make sure that everybody using MySQL right now as a catalog backend will be able to migrate smoothly. So then we have Python Bareos, which is a library to talk to the director and which helps you to script actions like configuring new clients, like triggering certain jobs. And that also supports encryption with the latest version. That's new here. Python Bareos itself is a little bit older, but now it's also using encrypted connections. And then we did a lot of performance improvements. So just an example, when we forked back in 2012 from the older Bacula project, we got a lot of legacy code. And one thing that Bacula did a lot was implementing common stuff by themselves, like checksums. So the old Bacula code contains own implementation of the CRC32 checksum algorithm, which is not bad, but it is very slow compared to modern standard implementations. And just by removing this homegrown checksum implementation, replacing it by a standard library, we got certain jobs like always incremental consolidation jobs, which heavily rely on checksums, faster by factor 10. Yeah, question here.
Question about the encryption. Is that public key encryption? Is it symmetric encryption?
The encryption of the data, if you do it on the client, is done with SSL, a public and private key pair. And the transport encryption is done by TLS and shared secrets. Okay?
Is there anything on the roadmap?
No, as far as I know, not, because the encryption using public and private key is the best I can think of right now. So we don't see any reason to do changes here. Yeah. Another question? No? Okay. So future direction, what's on our roadmap? Partitioning the file table is a customer request from the provider space. They have a lot of clients, and Postgres has the option to partition large tables by certain criteria. So it will make an own table for each client that's in the backup, and that will improve searching for files for a certain client and make it much, much faster. And we have done some tests here, and that's very promising. And it also will probably make backups itself faster, because the insert operations into the file table will get much faster here. Then we are working on new file daemon plugins. So for example, OpenShift or Kubernetes is something we are working on. Improve day-to-day user experience. Yeah, okay, so we will try to make configuration easier. That's especially important for beginners, because when you start working with Bareos, you have to read quite a lot in the documentation, and we will make it easier to start with pre-configured kind of standard scenarios. And then we start working on deduplication. This will probably not be ready in the next release, but at least we hope to have a concept. So a lot of users are asking for it. However, it's somehow strange, because when you do backup, that's about making redundancy of your data by intention. And then you do deduplication, and that means you throw away parts of your redundancy you've just built. So it's really a question of having a good concept here. So some solutions make it really in a way that they make deduplication on block level, and then you only have one block left, and there may millions of files relying on just this block. So you have to make sure that you have at least 2 copies of each block, for example. So when we are working on this, and with some help from a master student from the University of Den Haag. Yeah, question. Okay, was you? The question was, do we support compression? Yes, of course. We do support a wide range of compression algorithms. So we have added 2 or 3 years ago LZ4. That is the fastest and efficient thing that we have now. Yeah. Another question?
Yeah, deduplication is good as long as you're checksuming your data and checking consistency and verifying occasionally. The nice thing about dedup that we use it for is remote site synchronization quickly.
Yeah.
It helps if your data is like a bunch of virtual servers, you know what I mean? It really helps with this.
Yeah. Okay, so the comment was about that deduplication helps you when you make copies, remote copies to another site, and then you just do it one time for each block. That helps you. Okay, yeah, I can understand that. Yeah. Yes, yeah, sure. You have really to be careful if talking about deduplication. Yeah. But anyway, a lot of people are asking for it, and so we are working on it. Then talking about new device reservation logic, we have some limitations right now if you have large tape libraries with a lot of drives, and if you want to do a kind of partition, if you want to use it with, let's say, 2 different installations of Bareos, then there could be interferences, and we would like to implement the SCSI device reservation logic inside Bareos. So that's another feature, especially interesting for very large environments with a lot of tape libraries. Then we are always open for customer-funded features. Maybe one could be enhanced zero-knowledge backups. We will come to that later, what ideas we have around here. So any questions about future direction or even points you would like to see on the roadmap? Okay, then I go forward here. Coming back to the theme of the talk, Bareos and zero knowledge. So as said before, the backup data itself, that's encrypted. So that works. As said, you can have individual keys per client, and you can have optional or alternative a central master key. What about the metadata? So the Bareos storage daemon, you remember that is the part writing stuff to disk or tapes or so. The payload is encrypted or can be encrypted easily, but we still have file names, client and job information as part of the header of the volumes we write to the storage. Just show you an example. So this is the a hex dump or string export from a header. This gives you some information about versioning, about the name of the volume, but also here see that is the name of the Bareos server running in my private network at home. It says something about the version running, when was it built, and here it says something about this is the name of my laptop. Then this is the job, when was it run. Then you see here was a Python plugin used, and this information is needed on restore because some plugins require actions when the data comes back, so Bareos has to know somehow which plugins were used here. So, and then in the end here is a file name of what's going on next year in the backup, which was etc vimrc. So this is actually how it looks like. So you see still some information inside here that you possibly don't want to have there. So the director, if you run the director on premise, then it's no problem because then you are in control of the data here. But if you are using a backup of a service provider, then they will need some configuration files to control Bareos, and that will, of course, include shared secrets to authenticate the clients, the client network addresses, and what we call the file set. That's where we define what to backup. Simply a list of files, regular expressions, or scripts that will be executed to calculate what to backup. So these information are needed. We can't do backup without it, and it has to be somewhere. So, and you have to be aware when you do backups to a cloud service provider, he will probably need and maintain those information for you. So then we have the catalog, the SQL database, and that holds job logs, all the information that we retrieve while the job runs, job parameters, which source, which file sets, and it keeps track of the files that are in backups. They are in the file table. That, of course, includes the file name, size information, ownerships and permissions, and timestamps. So, and why do we need this information? If it comes to restore, we have several cases. One case is easy. If you want to make a complete restore of the whole job, you wouldn't need that data. For that case, it's okay. For disaster recovery or full recovery, you won't need the file table information. But in most cases, it's a requirement that you restore just some files or even one file. And then you have to look, where is this file? When did I make a backup? On which volume is this file? And if you do this kind of work, you essentially need the file table in the catalog, so you can't get rid of it. However, Bareos right now offers the possibility to delete all these file information inside the catalog. We use this to clean up the catalog after a backup job has expired, then you won't need the information. So, but you can also use it to improve security, that you immediately delete it after it has been written. So of course it's not optimal, but that's one of the possible enhancements to make it configurable that all this information is not written. So the summary is, we have the payload encryption, which is the most important part. We have pre-configured transport encryption. You don't have to configure anything, that's just done. And then we have some mandatory and potentially sensible data, like the configuration files. They have to be somewhere. We can't get rid of them. We have in the storage daemon header some information that we can optimize. We could reduce it and be still fully operational. And we have the job information in the catalog. And we have optional sensible metadata like the file information. I said before, we need this to have a certain level of comfort when it comes to restore. And just let me see. Yeah, and those information can be pruned automatically. So that is a state right now of what we can achieve when talking about zero knowledge or secure backups with Bareos. So, future potential. We could disable the feeding of file information into the catalog as an option, could be done. And of course, we could minimize the header information that I showed you in the storage daemon header. There are some things that we could reduce. And it's also possible to encrypt the file name in the storage daemon header. So that would be a minor effort, and implementations doing this as an option. And of course, the last line here, this is also subject for contribution. So we are an open source project and always happy if someone likes the ideas we have or likes to fund the development, which is also possible. Okay, any questions until here regarding doing secure backups with Bareos? Yeah, please.
If you're backing up a large amount of data, will you have several separate directors to distribute the load, or is there only one director that you schedule, you break up your backup?
Okay. Okay, question was about partitioning jobs if you have large amount of data and if we would recommend to do this with several directors. Usually life is easier if you have just one director, but we recommend to partition your jobs themselves into smaller chunks if it's too big. But you can still do it with one director. One limitation, the catalog database may get very big depending on the number of files you have. So at a certain point, it might be useful to have several directors, or you can also have several catalogs. So inside one director, you can make, let's say, chunks of jobs that you store in different catalogs, meaning several Postgres databases. Yeah.
So when you're backing up to, say, S3, when you're backing up to S3 Glacier, are you backing up to S3 first and then using AWS to transfer the data to Glacier or Glacier Deep Archive, or are you going directly to the archive?
I think the question now is on tape, right? So I don't have to repeat it. Yeah, okay. From our point of view, we don't care. We just see several S3 connectors offered by Amazon, and so it's up to you to choose which one you want. But what we can also do is we can copy from one storage to another. So for example, you could use Amazon S3, what is it called, disk storage, so the fast storage, and then you can trigger copying certain jobs from this to Glacier. This could be done. So a use case is that you have your incremental or the last full on disk to be able to do very fast restores and then migrate older fulls to Glacier for archive purposes, for example. So we can do whatever is behind the S3 interface. For us, it's the same. It's just one S3 storage, and what it's behind is up to the storage provider. Yeah. Okay.
So listening to you describe how everything works, I get the idea that there's going to be two main use cases for Bareos. One is used by organizations, either on premises or in a private cloud of some kind. And then the second being some sort of backup service provider who backs up customer data. At this point, when you guys, your roadmap and the features and how you're planning out everything, which one are you targeting or have a preference for in terms of making decisions? If there's a maybe a decision benefits one group at the cost of another, or you know.
Well, to be honest, that depends a little bit on our paying customer base. So, and right now we have kind of both. We have service providers that use Bareos to offer backup as a service. They come in with certain feature requests, like the file partitioning, for example, that came from a provider. And we have other feature requests coming in from customers, large organizations, large companies with large data centers and tape libraries, for example. And one feature on the map was the SCSI drive reservation logic. So that's coming from a large on-premise customer. But we also get requests from smaller or mid-sized companies that want certain features. So right now I would say it's a balance of all of it. Yeah.
I have a couple questions if no one else does.
Sure.
So if you have a commercial organization that's looking at this, But they won't do anything without support infrastructure. What kinds of support? I assume you've got full commercial support, 24/7, 365.
Okay, so there are two things we offer as commercial kind of support. One is a subscription version of the binaries, and that is pretty much like Red Hat does with Red Hat Enterprise Linux. So when we build a new major release, so the latest is 19.2, which we published in January, then of course the source code is on GitHub, and the binary packages we built for almost every current Linux distribution and Windows and macOS is ready for download on downloadbareos.org. There are ready-to-use repositories for each subscription. And then over the year, when we make patches and updates, they will always go into GitHub on the source code level, but the binaries we built with patches and updates will only be available to subscription customers. So that makes a difference here, just like Red Hat Enterprise Linux. But of course, for everybody who wants to use it for free, it's open source, can download from GitHub and build the packages themselves. So that's one point. And the other thing is support that goes on top of subscription. And there, this starts for small users with 3 incidents and goes up to 24/7 and unlimited number of incidents for large organizations. And again, we like to work together with partners here. So we prefer to have local service providers who do the local support, and then we act as a kind of reinsurance and help the local service providers when they get to their boundaries.
Related question, so if you're in an enterprise, and I saw you support SQL Server, Microsoft seems to drop a new version of SQL Server every 15 minutes. So how long does it typically take for a cutting edge company that's adopting the latest and greatest to get the support for the new versions of Windows and SQL?
Oh, that depends on the support case. So for the highest level, we offer 1 hour reaction time.
No, I mean to get the drivers.
The drivers.
Yeah, I'm assuming it's a driver-based thing for SQL. But sometimes there's a very long gap between when Microsoft drops the new version and when the vendor releases the driver.
Okay. So it's more the question how fast we react on new database versions. Oh, I don't have the numbers, but we use standard APIs from Microsoft SQL server, and I haven't seen many changes over the last year, so that's pretty much worked. And the same is true for MySQL. So the Percona extra backup interface works pretty well with current versions, so I don't see big gaps there. But that was the question.
So the past 2 versions of SQL Server, I haven't seen any lag on support from Bareos to support the new database versions, so it's been good.
What about the competitive landscape if you compare Bareos to other open source or even closed source? Obviously, you have the open source advantage, but what would you say there?
Well, there are other open source backup projects around. As far as we know, we are the only one that offers subscription and support services for a full open source version. So that's the biggest difference there. Of course, if you compare, for example, Bareos to, let's say, Veeam, which is very widely used among VMware servers, a commercial version or commercial product, that is much far advanced than we will probably ever be in the field of VMware backups, because it's very specialized and very good. If you compare to like big things from IBM, Spectre, they have enterprise features that we don't have at the moment. But on the other hand, we are much more flexible with our plugin interfaces, for example. So it's very easy to write Python plugins to back up certain applications which will be much more difficult using one of the big commercial programs.
And speaking of doing development, I asked earlier about the symmetric key encryption. There are many companies that have very, very long data retention requirements into like the 30-year range. So today, the quantum computing threat to the public key encryption may not be an issue, but when you have a 30-year window, it becomes an issue today. And so, you know, what would be the feasibility of getting a symmetric key encryption that's more impervious to the forthcoming, although not today, quantum computing threat?
Well, if it, I mean, symmetric means you just have one key, not a private and a public one. So it makes a difference of maintaining 1 or 2 files. And if you want to, I guess the intention is to make it easier from a maintenance point of view. Right now, we can already do encryption by just one key pair, a central key pair on the Bareos server, and then you keep the private and public key there. So I don't see a big point in having it for symmetric encryption.
Well, the problem is that the elliptical curve encryptions and so forth are considered quite hackable in a quantum universe. But the symmetric key encryption is considered not hackable.
Okay, from that point of view, yeah, that might be a thing that we should consider, yeah. But, okay.
I would say when OpenSSL adapts to that, they're going to automatically benefit as well, you know, because they're using library for encryption. So.
Yeah, right.
Well, if and when, we don't know when
yeah.
or. Yeah.
So typically when people talk about using public key cryptography to encrypt something, what they're really talking about is using a randomly generated symmetric key for encrypting the actual data or the bulk of the information, and then using encrypting that randomly generated key with the public key cryptography. So realistically, if that day ever came, it would be a matter of re-encrypting headers that hold that randomly generated symmetric key for any sort of asymmetrically encrypted files. So it's a much different problem to solve.
Yeah.
Yeah, but the problem is that if you've got 30 years worth of tape sitting around, that's not really a feasible project. You need to secure now for the future, right?
Yeah, so the point is we are not encryption experts. And I think you said as soon as OpenSSL, for example, has new features, it's easy for us to adapt it, but we won't get involved into SSL implementations by ourselves. It's not, we can't just do that. So we rely on what the community from the encryption people offers us by means of standard libraries. Yeah.
Yeah, I mean, typically public key encryption is used to encrypt the symmetric key. Mm-hmm. It's not used to encrypt large blocks of data because it's too expensive. Mm-hmm. And so if you have a master symmetric key, you can encrypt it with public key encryption with a very large key to keep it safe for a very long time. Yeah. And that's the trick, is just the proper use of public and symmetric.
Okay, I keep this with me and talk with my developers what they think. Thank you. Okay, so any other questions you wanted? Yes, right. This is the last slide. So here we have a user mailing group and a developer mailing group, and of course a GitHub repository. We have we are on several events. So the next one will be Open Expo Europe in Spain. That is at the beginning of May, and we have our own conference called Open Source Camp on Bareos in Berlin. That's around June. Okay, so thank you very much. Then, yeah, it's fun time.